Hello, and welcome to DecentraWise Podcast. My name is Pedro.
And I'm Miguel, and you just joined us in our mission to decentralize the world wisely.
Wisely, it is. So, what better way to decentralize the world wisely besides dump contracts?
Yeah, well, first of all, you need to grab your drink, sit back, relax, and
Of course, of
we
course.
are about to get really nerdy today. So we are
I
going
have my
to,
coffee,
yeah, I have my water. Oh, I'm almost out of water.
and yeah, we have a very cool episode today because we will do some live streaming, some live coding. Live
Yeah,
streaming is every week.
yeah, guys, let us know if you enjoyed this format, and so that we keep bringing up what you guys enjoy most.
But
So
before you do all that, there are some buttons down there to
ooh,
press. If
buttons.
if you
Nice.
didn't press yet, you should, because
Yeah, there are these buttons that say like, which is a thumbs up, and subscribe. You can also share. Please, guys, share with your friends. This is absolutely wonderful content that we are giving to you guys. So don't
and
forget to share with your friends.
and we
And
are almost at 400 subscribers, which
yeah,
is crazy. And
uh,
yeah,
it is. We have to have a party when we get to 500, and another party when we get to 1,000. So let's aim for that, guys. So please subscribe and keep watching us. It helps us a lot. And also share. I was saying share with your friends, because it makes you a really good friend if you share this content with them.
and
And in your social networks, just share our stuff.
and
It's
don't
cool.
forget,
Help us a lot.
uh, this is a community thing, right? It's not just that we are here to uh, do some live streams and get more subs. We want to build an interesting community here.
Yeah, don't get us
So,
wrong. It's really fun to do this, but it's really more fun if you guys interact with us, and so that we can try to give you guys what you guys are looking for the most.
we
So yeah,
are we are very experienced in Web3 already, and we want to share and want to share our experience with all of you guys. So that's the purpose of this thing. So join us in our social medias. We have a Telegram channel where we hang out pretty much every day. Uh, get there, ask. Uh, uh, there's plenty of people there to help out and to discuss all the subjects. And yeah,
yeah, and you
let's
can find fellow Web3 developers there, that you guys can talk and also raise questions together. Uh, let's have some fun with this, guys.
yeah, and a lot more stuff to come. Will be announced exclusively on our Telegram channel. So another reason for you to go
Yeah,
there so that
exclusive
you can.
content there, guys.
Oh yeah. So, but let's talk dumb contracts, or more in another way, smart contracts that are not that smart.
Yeah,
Because
this is kind of a stupid contract, right? We are just going to show you guys how to make a really simple contract, and how to go about on doing it, deploying it, and testing it. So this is going to be fun. We are going to finally do some code here, so that you guys can
oh
see
yeah.
how to do it, and how easy it is to make a smart contract.
So what will we be using today, Miguel? Uh, you are
Yeah,
the
well,
coder today, so
yeah, we are going to the simplest way, which is using Remix IDE. Uh, I don't use it quite a lot, I usually go for VS Code, but yeah, let's go and try to get around and show you guys how to do it in in Remix.
Yeah, nobody uses Remix quite a lot. I think people use Remix to do X and to experiment with stuff and so on. That's the purpose of it, and it's quite useful for that because you don't have to set up anything. You just run
Yeah,
Remix on your browser, and you are set. It includes everything like a running blockchain that you can deploy stuff to it and
yeah,
call the functions on your contracts to experiment right out of the box. It doesn't take you a single click. Um, and it connects to everything. So if you also have a wallet and MetaMask installed, for instance, and stuff like that, it just works as well. And you can connect to test nets, to mainnet, deploy stuff. I don't suggest that it's a good idea to use Remix to deploy stuff on mainnet, but I've done it and it
yeah.
works.
Well, it works,
Uh,
right? So it
but
just depends on the complexity of your deployments.
usually when you want to deploy stuff to the mainnet, you should do it in a more production type of thing, like with deployment scripts, with proper variables to hold your secret information, like private keys and all that, right?
Yeah.
So yeah, but you can connect a wallet and do it with Remix. Not a big
Yeah, well,
deal.
if you are playing around with Solidity, you can just do it, right? It's nothing important,
Yeah,
so
and
you
for
can
doing quick
do it
tests,
easily.
it's the best way because you don't have to set up mostly anything, right? If
Yeah,
you want to set up a hard hat project or a Foundry project or whatever, there is a lot of boilerplate that you have to work around before you even start to write the first line of code, right?
yeah,
And uh, with Remix, it's done. It's just
yeah, yeah. Well, it's
open
working.
and start testing things. So that's why we decided to use it for this first version, for this first live coding experience, because it's a good option for a beginner to start
Yeah,
there,
well,
right?
for you guys that are just starting getting into this, this is the perfect way to do it, and the easiest for sure. So yeah, that's what we are going to show you guys.
Okay, so let's go.
Yeah, let's start with it.
So we have Remix IDE here, and it's asking for
Yeah, this is
acceptance.
the first the first thing that you see when you get in, right? So it just it's asking you for an opt-in version of Matomo, whatever, uh, and yeah, well, you just accept it. And now, welcome to Remix ID. So it's just asking you, what are you going to do? We are just going to select, like, this is learning and discovering the Web3 development. And yeah, okay, next. So it's just showing the buttons here and the tabs that with the functionality that we are going to use in the near future, guys. So this is the Remix IDE. So we can start here with the contracts. This is these are the example contracts that just give you just out of the box, and this storage contract is just something that it stores on the blockchain. So it has the contract here, named storage, curiously, and it stores this number, which is a 256-bit integer. and it has a function to store the number and a function to retrieve the number. So it's a get and a set function. So yeah, this is quite simple.
Yeah, there
Do
are
you
a
want to
few
say anything
things.
about this?
There are a few things to say about these contracts. So there is a store function that is the
Yeah, let's talk.
function.
Let's talk a bit about the accessibility
Yeah.
of the functions here.
So whenever you declare a storage item in your contract, it is like a memory block that you are able to write stuff in, right? And that is the variable number there. So all the variables that you put in a contract are requesting from the blockchain a slot space to store information on. And usually, at least on EVMs, each slot is 256 bits, right? So if you have a UINT 256, it will occupy an entire slot, right? And different variable sizes will require less less storage amount, and then Remix groups the EVM groups the variables it can by order, by the order they are declared. So you have to take
Yeah,
care with the
what you are
positioning of
saying.
things.
Yeah. Let me try. If you do something like this, and this is. Let me try to show you guys this BBB. Okay, so this will take. This is not the
3
same as
slots.
doing this. Okay,
Yeah.
this is not the same. This will
In
take
this
much more
case,
space.
it will occupy 3 slots.
Exactly.
So you will pay gas fees for 3 slots
For three,
occupied.
like it will take the same space as declaring 3 variables with 256.
So
This will be optimized, and it will join these two in one slot of 256 bits.
exactly. So that is one important thing, right? You look at your storage variables, and you should always think about how can I group this in a more intelligent way so that I occupy the less space possible and save on gas, right?
Yeah, save space, and it will be cheaper.
And
yeah, we have this 256, so we are just taking one slot here. So yeah.
And then you have the function store, which is a public function. And there is another optimization that we can do here. It can be external instead of public, because public functions are usually available, of course, outside the contract, but they can be called from inside the contract as well.
Yeah, let me exemplify you this. So I could call store here inside, like this.
Yeah.
Okay, and this is why is it giving me? Oh, it's because of the accessibility here.
Yeah.
So let's create another function here.
So you don't need the D's anyway, because
right. Function test, and let's put it here like also public, and we can call the store, not storage, store with something here. Okay, so then this is valid code here, but if you declare it as external, this is not valid anymore. As you can see, we have an error here saying that store is not visible at this point, because it's not visible internally to your class, to your contract. Sorry.
Yeah.
So making it public will make it available again inside their
Yeah.
class. So
Why
external is
this
only
is
accessible from
important?
the outside.
This is important to save gas. Another thing, right? An external function uses less gas
Yeah,
than a public
let's
function,
see
right?
if we can see it here. Let's take this out. Well, actually, it's saying that it's the same. So I don't know.
It should have
It's
a very minimal difference
yeah.
um, because that's how the EVM works, and because it also makes things more uh, individualized. What can be called from the outside only, which is the public interface, and the internal functions, right? So
Mhm.
it's a good idea to think about what needs to be external and what is required to be public, right?
Yeah, about the gas, you can always keep tracking of the amount of gas that the function is using by here. I'm not sure if this is really very accurate, but you can
Yeah,
at least have a notion of how much
it's just an int,
gas it's
but
taking.
yeah.
Yeah.
So retrieve function has a different thing, which is it is public view, and that's another important thing. That one is very important because a view function takes really a lot less gas. So uh, the important thing is that the view function is only able to retrieve values and not store values, right? It's a
Mhm.
read-only function, right?
Yeah.
So that's why it requires a lot less gas because it's just accessing the storage and
Yeah, there
returning
is
some
another.
information.
Yeah, there is another keyword here that we can just talk about, which is uh, the pure modifier, which because when we are returning number, this is accessing the storage,
Mhm.
the blockchain storage, and the pure views are just if you let's try
A pure
one here.
function in computer science is a function that doesn't have side effects, right?
Yeah,
So it doesn't write anything and it doesn't read anything from anywhere,
yeah, exactly.
right?
That's the most
So that's
the biggest difference here
yeah.
is that it doesn't read anything. So just come on, you're making me write everything. So an example of this would be this, right? Returning one. Why
Returns.
returns? Yeah,
There's an S.
right.
Yeah.
So this is not accessing the storage, right? So it can be pure, and this is the difference from view to pure.
Yeah.
So yeah, just notice the difference in gas. Okay, it's just the same function. It does barely the same. It's just not accessing the storage, so it has a huge amount of difference when
And you
when you
can
look at the
you can
function.
s- pass you can pass values in. So this function is not a function very common, right? But you can pass values in so that it does something useful, right? And
Yeah.
yeah, something like that. So
Well,
uh,
it actually takes infinite gas, so nice. Yeah, so that's what I was saying. I don't know
as you
how
can
accurate
see,
this is.
the gas hints there are very uh, not very accurate. But anyway,
Yeah,
yeah,
well,
but
it's not.
that's
It's yeah,
that's the idea. The idea of a pure function or a view function is it's to save gas and to by
yeah,
restricting the actions that can be performed, right?
yeah. So this is a way for you to model your contracts. So the
Yeah. Let's
accessibility, how they can be accessed, and how they can be used
Let's try the
along
contract.
the. Okay, yeah. Let me remove this. We don't need this. Let's try this
Yeah.
one. Okay. So
So
we
first,
are going to
you need to
here
compile
for.
it.
Yeah, we are going to come here to the Solidity compiler and just press the compile button here, and it's done. It's compiled. So now we can deploy and run the contract. So we can take right now the default selection on the environment, which is the Remix VM. It's running pseudo blockchain in the browser. So yeah, let's just deploy this.
And we have a green check mark, which is
Yeah,
amazing.
green check marks are good. Are always good news most of the time.
So you
Uh,
deployed
yeah,
the contract, and there is deployed contracts at the bottom, and you have that contract address.
Yeah,
Uh,
so this is the address where the contract is living right now, and it's showing here our store function, which takes a 256-bit integer, and to which we can just let's try to retrieve first, right? So if we try to retrieve, it's returning 0 because it immediately when you start the contract, it initializes everything to 0. So as soon as we try to put 10 and let's run, well, there you go, guys, a green check mark. Good news. So I think it went well, right? We should now have 10 stored in the number variable. So let's try to retrieve it. And to retrieve it, we just press the retrieve button here and it returns 10, which is good news because that's what we were expecting. So
and we should have
yeah,
spent a small
yeah,
amount of ether.
do we see the
Uh,
gas around here?
you can
Is
check up on the left. No, on the left. There are the accounts at the top of that window. Not yeah, there. You can see the account there. Yeah, exactly that. If you click that,
yeah,
you
okay,
have
okay.
many accounts, and that
Yeah.
one is has already some gas.
Yeah, so if I'm not wrong,
Paid.
you can change the account whenever you want, and each time
Yeah,
you run a transaction on the contract, it will use that selected account.
yeah. And if you want to call a function sending some value, some amount of ether, you can use the value there to pass ether to a function.
Yeah, okay.
Of course, in Solidity, a function to accept, to be able to accept ether, right? It has to be a payable function.
Yeah.
Okay.
So we have also here the published IPFS, which we will cover in the future. So let's not just talk about this right now.
Oh yeah. So
Sorry, guys.
So we have deployed the first contract. We have
Well, happily deployed the with green check marks. Nice.
yeah,
So
exactly.
happy that I am.
So if you want to check the gas, you can
Nice.
have it there. There is the
We have all
gas.
we have all the data here. Wait up.
Yeah. There is the gas that you paid for storing 10 on a blockchain. Like
Yeah.
a gazillion gas just to store the number 10.
Exactly.
And today that
This is very
Ethereum is
useful.
almost at all-time highs, this is getting expensive. That's why it's fun to do it in the browser, because if you have to do it on the
You are not
blockchain,
paying for that.
you would pay.
You would be very sad when you see these green check marks and go here and say execution costs and transaction costs. Those are really heavy. So if you wanted to translate this to dollars, this would be like what, $2, something like that.
I'm not sure.
Yeah. So yeah.
Anyway, it would be too much to store at the number 10.
Yeah, yeah, it's
At
just
least for me.
pointless.
I
Yeah,
wouldn't like to
yeah,
spend that amount of money.
yeah, and keep in mind that these contracts are well, if it's a used application, it will be recurrent costs. So every time that somebody in the world just pressed the store button, you would pay that amount of gas.
You know, they would pay, right?
Yeah, they would pay that amount of gas.
It's not that
So
bad.
yeah,
Uh,
so
usually the one the costs of a contract are the costs of deploying the contract, which is another transaction that should be there, which is
yeah, it's probably
probably
this first one. Yeah,
more expensive, right?
yeah, a lot more,
Yeah,
like 10 times more.
it's a lot.
Yeah,
So
we are talking
having
about
having that in
a lot.
mind is very important. The shorter you make your contracts, the more optimized they are, the less they cost to deploy,
Yeah,
and the less they cost to use. For your users will thank you,
exactly.
right?
Yeah, because you have to have into account those two parts. You have the deployment cost, which is usually depending on the size of the contract, it's usually quite big, and then you have the operational costs, which is every time uh, a function of the contract is called. It will have its inherent costs. So yeah, you have to account for both.
But one thing is very good. Uh, View functions or pure functions cost nothing.
Yeah, that's good news actually. Yeah.
So usually that is a good thing. You
Yeah.
can call them without paying any uh, any amount.
Yeah, actually, because it was saying there that function my pure, and let's have it public,
That's wrong.
pure returns 256 return 100. So, yeah, let's make it different. So it's saying that it has this gas here. Let's try it out. Why not?
Yeah, try with the different accounts. Select
Yeah.
another account.
And let's deploy
You
it.
need to deploy another contract.
Yeah, so there we go. Oh, crap. Let's have another account then.
Yeah.
And let's go to the second deployment, which is this one. You can, when you get a contract that you will be recurring, you can pin the contract and use it right out of the box. So let's try to call this. I want to clean this up.
Yeah.
Clear, and let's try to call retrieve, and we will get 0. Nice.
Yeah. It's a new
Why?
deployed contract.
Yeah, but I'm hard coding it to 100.
No, my pure. You need to click my pure.
Crap.
No problem. No problem. It didn't cost anything.
Yeah, right. Okay, my pure, and
You
there we
get
go.
100.
Yeah, that's fine.
And
Let's see how much did it cost. It doesn't have costs.
yeah, it doesn't have because
well, I thought it would show here, like it costs 0 gas. Okay,
it actually has
that's fine with me.
execution costs there, but it's
yeah, execution costs.
yeah.
Why shouldn't it be
Because
0?
that only is taken into account if called by contract, because usually that means that it is function that requires access to the blockchain. So write access. If it is a pure function, no, or a view function, it doesn't cost anything.
And then why is it showing here that it
Because
costs?
there is execution being done, right? So it requires some throughput of the virtual machine, right?
Yeah.
But that's the way things are done. If you check the account above, it's still 100 ether there. Check the account.
Yeah. Yeah, for top secret, he's asking what contract are we doing? We are just going around here the default contracts that are created as soon as you start Remix. So we are going around this storage and trying to work around and make some tests. We are now checking the gas of calling some functions of the contract. So so we have this one. I think we covered most of it. Do you want to talk about?
Let's move to the next.
Yeah, let's go. Let's try this owner contract. So what does the owner contract do? So yeah, from the name, it's like having access permissions only to some functionality, which is quite usual when you are making a smart contract that you have functions that are only accessible to a certain wallet. So
which represents that your contract is probably not decentralized.
Exactly,
right?
because because you require one single access for that. So yeah,
the things when you are thinking about decentralization, DecentraWise is the place to come to do it wisely. And if you see a contract that has an owner, that's one
it's a single point of failure,
point,
right? Yeah, it's a single point of failure.
So
what you should do in this case is to have a multi-sig. But yeah, we are not covering this right now. We are just going for the simple stuff. So what we are saying here is having a property on the contract, which is the owner of this contract.
And in that case, it's a private property, right?
And you don't want to have it accessible. Well, you only want to have it accessible through functions. This is what it means. So you
address
have also
is the data type, which is it stores an address, right?
Yeah, exactly.
In this case, the address of the wallet of the owner.
Yeah.
Right.
Yeah. The next line here is an event, which is most probably going to say, well, we change the owner to this address. So if you are on the outside of the blockchain, you can listen to these events and capture these events in order for you to react to some events that happen in the contract. And this is what will happen here as soon as we call the function to set the owner. It will trigger this event or emit this event.
So this means that when you think that some actions on your contracts may require other systems to hook up to, you probably need an event for that. And you can pass in the event, you can pass data to the outside world, like the address that changed, the amount that was sent, stuff like that, right? Mm-hmm. So that people can receive a message with more data that they need to do stuff, right?
Yeah.
So in this case, you are passing old owner in and new owner. So
Yeah.
anyone listening to this event will receive all the information, right?
Yeah.
The old account that was before and the new account that is after the new owner,
Yeah,
right?
so we will see further ahead that we have a change owner function or something like that that will be triggering this
Yeah.
event. So in the meantime, we also have a modifier. So what's a modifier?
A modifier is a cool thing. It's more like a syntactic sugar kind of thing. So the idea of it is when you have checks that are repeated in your code, you can put them all together in a modifier and use the modifier as uh, a prefix to your
Yeah, so
functions, something like that.
it's not only prefix because this will represent your function here.
Yeah,
So it will execute this and then the function here. But you could have some other stuff here after the function also.
yeah.
So
So it's a
let me
wrapper.
show you guys. Yeah, yeah, it's a
It can be a
wrapper
wrapper
for this.
that
Let me
does
show you guys on the
stuff.
functions. If we this is using that, so it's this is owner, right? So it's modifying this function to do that we have there. So if we wanted to reproduce the same behavior there, we would have to do this, and it would do
Yeah,
exactly the same thing. But if you have more code, this is right, really simple stuff. But if you have more code, you don't want to be repeating all this stuff. So you just set the modifier that you want to the function, and it will just work like we were saying. It does whatever you want. You code whatever you want. Then this symbolizes your functionality, and then you can do some other stuff. So yeah,
yeah. It makes your code more readable,
yeah,
and yeah.
more dangerous too. But there you go. uh, but yeah, it's usually a good thing to use. So now we have the constructor. So if you guys are used to object-oriented programming, you know what a constructor is. It will run when you deploy the contract and when the contract is initialized. Console log, if you are used to JavaScript, you should know what this is. So it will just print stuff on the console. And by the way, this is not, you cannot use this out of the box. You will have to import this hard hat console.sol contract
Yeah,
in order to have this functionality available. And so in the constructor, we are setting the owner as the guy or the wallet that it's deploying the contract. So that's why this message sender here. And then, like we predicted, because we have crystal balls. This is not. Man, come on.
not again, man.
Yeah, we have
Not
to
again.
stop. We have to
Can't
stop
we
with
have
this.
a live stream without balls involved?
Yeah, we have to stop with this balls analogy. So yeah, we have like we predicted, we are just emitting the the event that we spoke before, and to do that we call the keyword emit and then the event, and with the values that we want to send on the event. In this case, address 0, because as you know, as we spoke before, every contract, every property before when the contract is initialized is 0 if you don't set it to anything. And then the owner that we just set as the message sender, which is the person that is calling the transaction. Well, person wallet. What do we have here? We have the change owner. So, in
Yeah.
my opinion, this shouldn't be here, and we should call the function. It wouldn't cost you any extra gas. It should be called here. Well, in my opinion, so I think it would
Yeah.
make a cleaner code. So to have it, we should have this with message sender. Yeah, it would be cleaner instead of this.
Yeah.
But yeah, well,
Since change owner is public,
yeah,
it could be external, and then
yeah.
it would save gas in the long run and cost a little bit more in the constructor. But yeah.
Okay, so what change owner is doing is emitting the event and setting the owner in the storage
Yeah.
variable that we have here.
Yeah.
So, and keep in mind that this is private for a reason, so that nobody out of the contract may set it, and you wouldn't know anything
May
because it wouldn't even emit the event. So, yeah, it's encapsulating the variable.
Actually, that is a very important thing to talk about. Nothing in blockchain is actually private, right?
Yep.
That keyword is only preventing the Ethereum compiler from generating getters to access that data. And so that we use a specific function to access that data. But everything in an Ethereum contract or EVM contract is public. So without having anything, any specific rights whatsoever, you can just go to the contract address and read the storage of it
Yeah,
without any problem.
you are saying that it's public, but it's public only for read, so it will be read only. You cannot set, even though it
No.
would be.
You can never
Yeah,
set internal variables on the contract besides using a contract function. The
yeah,
only That's the only way to change the storage of a contract is to
yeah,
go through the contract functions, right?
yeah,
That's
exactly.
it. But
And
for read, you can access it without any problem.
mhm, yeah,
So we can go to storage and read it.
yeah, and you can just check the values that are in a specific address and check what's going on there. Okay, so and finally we have the get owner, which will just return what we have in storage.
Yeah. So if we
That's
didn't
it.
want to
Easy.
write the code for the get owner, we could simply mark the owner as public, and
Yeah,
then the Solidity compiler would generate a function called owner
yeah,
and give us the value. It would be exactly the same without having to write anything,
yeah,
right?
exactly.
So in the beginning, in the earlier versions of the Solidity compiler, that would cost a little bit more gas. I don't think that's the case anymore. So the getters are very optimized already as well. So I use get automatic getters a lot, and yeah, it simplifies the code. We don't need to have getters all over the place, right?
Yeah, yeah. Well, it simplifies and then it cleans up a lot of these getters. Uh, okay, so shall we deploy
Yeah,
it and
let's
try it out?
deploy the thing.
Yeah, compile and
Maybe you can clean the
owner deploy.
contracts already deployed so that you don't.
Yeah,
Yeah.
yeah. Okay, so let's deploy it. It's
And we
done.
have a
It
green.
costs a lot of gas, and with a green check mark, which is good. It's great. It makes us feel good. And the gas doesn't make us feel good. It makes me nauseous to look at these values. It costs a lot of money to deploy stuff. But you guys, you can always make the contracts shorter.
As you can see, there is a console log there that shows you at the bottom. At the bottom, yeah.
Oh yeah,
The
yeah, yeah.
owner
Oh yeah.
contract deployed to the address, blah blah blah.
Exactly.
Right?
So the console logs that you can see here, they will show up here. Do we have any more logs? We can put some logs to show people on the change here. Console log. Changing address to. We don't need space. New owner. There we go. And let's put another one here.
That you can't.
Oh yeah, because it's a view.
It's a view,
Oh,
and
really?
that is the console log. The way
Let's try.
Hard Hat implemented it is through events. So that's why you will not be able, because that would require you to have it. It allows. That is strange.
Well, let's try it. I don't know. Let's compile it. It compiled, and
Really?
it's deployed.
I would assume that it wouldn't allow.
Yeah.
Okay.
Okay. This is nice. Okay, so let's go for
I don't
this.
use
And
console log that much.
yeah, well, this is really useful to debug
I
some
know,
stuff,
but
right?
I usually don't use it. Let's check the events of the open that deployment on
Yeah,
the
it's here
no the, on the console. Open the deploy
on the debug console. What do you mean?
on at the bottom on the check mark, the green check mark. Open it and let's see the logs.
Yeah, the logs. This is the log.
But I'll go a little bit up. That is the topic. There is the just the
Where?
logs. The rest I don't want. I just want the logs. Down, down.
Yeah, yeah. This
I
is
want the
the
full
thing.
logs. It's up, man. Yeah, that one. That one.
Okay.
You see that there is a topic and owner set and so on. Yeah, that's just the event that we use. We are not seeing the console log stuff.
What do
Strange.
you mean?
Okay, because from my understanding, console log would to use events to
So let's
send the
see.
information to the outside, but it's not there. So
Yeah, it's nothing, and I don't know what it's using actually.
yeah,
No
strange
idea.
stuff.
But
Uh,
we are getting the events, so it's
yeah,
pretty
we are
nice,
getting
guys.
the log.
So yeah, if you want to debug some stuff, you can do it here. So let's try it out. So let's choose another one. Copy account. Change. So the one that we deployed the contract with is this one, which ends up 02 dB. And it should change to this one, AB. Well, AB, it's nice. It's easy to memorize. So yeah, let's call change. Well, let's clean this up so that we don't have this mess. And change. Whoa, it failed. Why? Mine, but execution failed. Why did you fail? Revert. We don't have anything here. I'm betting is this console log. Why
Why?
is it?
What happened?
Why is this not accepting this? Isn't this the format for this? Yeah, it is. Why is it not accepting this? Well, it failed. Color is not your. Oh, crap. We need to change this back. Yeah. Well, I don't know how to read this properly. Okay, let's do it. Clean this up and poof, now we have a green check mark like we like it.
You wanted to hack your own contract.
Yeah, that's right. Yeah, changing address to blah, blah, blah. And now we can see here the event. So this is the event, and we have the old owner, like we have here, and the new owner, which is this AB, and the old owner is this 02DB. So the events are quite good. What are these? Oh, yeah, because you can access the arguments with 0 and 1
Yeah.
and by the name. So yeah.
Yeah.
So you can index the arguments and or get them by name. So yeah, they will have the same value, and this doesn't cost anything because it's just getting stuff out of the blockchain. So yeah, I think we kind of covered. Do you want to say anything else about this contract? Does it make sense to keep going, beating the crap out of this?
I was just investigating in while you were going through how the console log is implemented.
Yeah, can we go there? Oh,
And
assembly.
it's a bunch of assembly stuff,
Oh crap!
static
Really?
calls, and blah blah blah. I bet that this was implemented using events back in time, but not anymore. It's
Yeah, probably.
doing some magic, probably with the virtual machine receiving this and in a different way without events. So yeah. Good.
Yeah, well, we are not going through the assembly today.
Why not?
Through this. Do you want to go there?
No.
Yeah, well, we can make an episode just talking about the little assembly. You guys shouldn't be using the assembly at all. It's really,
why not?
Error, because it's error prone. Come on,
You should.
don't teach,
You should.
don't teach bad stuff to the guys.
You
At
should
least not right now.
hack the hell out of the EVM right from the beginning.
Yeah.
Start with assembly.
Okay, so I think we covered this contract. Shall we go to
let's go to the next one.
Ballot. Let's close this and this. Yeah, let's just talk a little bit about this stuff. So these are the dependencies that are installed in order to build the contracts. As you can see, you have the console log, the console.sol contract as a dependency. The state, it will just, yeah. This, what is this?
It's the state of the VM running in the browser.
Okay. Yeah, whatever. And you have the contracts here. Let's go to ballot. Okay, so ballot implements voting process along with voting delegation. So for you guys that don't know what delegation is, it's like when you have an election and you elect somebody to represent you. So this is a really small implementation. You have a structure here. So if you guys don't know what a struct is, you should check it out. It's a agglomerate of properties. And again, so this uint, it defaults to 256, if I'm not wrong.
Yeah.
So this will be the weight, and the weight is the power, the voting power of this voter. Voted, it's a boolean, which is saying whether it's the voter already voted or not, and the delegate will be an address to a wallet which will represent this voter. And uint vote, what is this uint vote? I have no idea.
It's the index of the proposal that this voter wants to vote on. So it's the vote of the voter.
Okay, so let's see how this works, because you have a structure with a proposal, and it has a name and a vote count. Okay, so I'm figuring that we have a mapping of address to voters and an array of proposals. So okay, so I think that each voter will vote on a specific proposal from a few proposals. The voter will choose one. So I think
exactly. So the contract is initiated with a few proposal names, right? And those are the options for the voter to vote, right?
Yeah.
And each voter is initialized by a chairperson, and that chairperson has the power to say what is the weight of each voter, as far as I recall, and then they are able to vote for themselves or delegate their votes to somebody else that will vote for using their weight, right?
Yeah, so we have this this chairperson, which I'm figuring will be the responsible guy for this contract.
That's the one.
Yeah. So what we are saying here in the constructor, we are receiving the names for
the proposals.
We are saying that it's memory because it's more efficient to pass parameters as memory when possible. So this is only useful, if I recall correctly, if you are passing arrays or strings. So we are setting the chairperson, which will be the responsible guy, as the message sender, which is the person that is calling the transaction, or here deploying the contract. And we are saying that this chairperson has a voting weight of 1. Now for the proposals, we are pushing the proposals into storage, and yeah, we are just initializing with the name and the vote count of 0 because we are just initializing. Would this be necessary or mandatory? I'm not really sure if we remove this.
You need to pass it because it's a struct.
Exactly. Yeah, exactly. So it's not initializing to 0.
It is initializing to 0, but you would have to do it in another way.
Because
you would create the proposal and that just assign the first one.
Exactly, because this is like initializing with the parameters, so you have to pass them all. Okay, so the next function is give right to vote. So it will give the voter the right to vote on this ballot.
So that function is only callable by the chairperson?
Yeah, well, so if we would follow the example of the owner contract, we could make a modifier in order to guarantee this.
It's not needed because it's the only function that is
probably
using that. So that's
maybe. So what we are doing here is calling require. Require is like an assert on other languages, and it makes sure that this is true. So if it fails, if this is not true, if this assumption is not true, it will return this error. So this
Yeah.
is what the require does. It rolls back everything. So imagining that you would be doing some stuff here, it would roll back everything that you did before.
Yeah.
So we have the other require here, and we are just checking that this specific voter has not voted yet. If it did vote, it will return the error. Well, not return, it will just immediately roll back everything and saying that the error would be this. The voter already voted. And we have another require here and saying, guaranteeing that the weight is 0. I don't think this is necessary at all, but it will roll back everything. But it
Yeah. It's
has
just
nothing to
it's
roll
just
back.
to mark that if the transaction is not succeeding and
Yeah. Yeah,
paying
well,
all
it's
the
yeah,
gas,
it's failing. Yeah, it's failing the transaction.
uh,
Yeah.
if the voter already has the right to vote, right?
Yeah, exactly. And if everything was successful until now, it will make the weight, the voting weight to 1.
Yeah.
Okay, so let's here talk a little bit about this delegate and delegating your vote. You would have to say, well, my representative is this address. So that's what we are passing here, the address to. So we are grabbing our the person that we want to set the delegate, and we are grabbing from the sender. So the person that is calling this transaction is imagining that it's I want to delegate my vote to somebody else. It will have to be my wallet to call this delegate function, and it will get my structure, this structure that identifies my wallet into
Yeah.
this
Let's talk
into this
about
variable.
the mapping because we stepped over it.
Yeah.
There is
Probably we
there is
should.
a
Yeah,
special data structure up there, which is the voters mapping, which is uh, a table that associates addresses to uh, struct voters, right?
yeah,
So that means that uh, e- for every address that we set on that mapping, there will be a voter struct with data that belongs to that address, right?
yeah. I mean, in other languages, this mapping would correlate to maps, to dictionaries.
Yeah,
So yeah, if it's easier for you guys, this is usually called the dictionary, which is this is the key and this will be the value.
yeah,
So
exactly.
it's like a key value structure.
And it's very
Uh,
useful because it's very efficient in
yeah.
Ethereum, and so we use it for everything.
Yes, yeah. So this is the mapping, and we probably want to go a little bit about the arrays also.
Yeah, that's the regular arrays. So proposals will have an index uh, that is a number, right? So you can loop through proposals. And in a mapping, you cannot loop through a mapping. You have to have the address because the way if the Ethereum virtual machine organizes data in the storage is by the hash of the supplied index of the supplied data. Like in this case, is an address. So uh, it will have it will construct the storage address based on the mapping itself and the address that we supply. So
Mhm.
it's very efficient because of that, because there is no it's a direct access to the storage, right?
Yeah.
And arrays are loopable because they have
Yeah.
numeric indexes, and usually they are stored uh, in the subsequent places
Yeah.
in the storage.
Yeah,
So
and I think that's the main usability difference between the two of them, which is the array is loopable, uh, and the mapping is not. So you need to know what you are addressing,
yeah,
which keys you are putting in. Okay, so let's keep going on this one. Where were we? So yeah, we were here on the delegate. So we are just getting putting the person or the wallet that it's calling this delegate. We are just summoning into
getting the
this
structure
variable.
there.
Yeah.
Yeah,
And this storage keyword is important because it means that if you set anything on this variable, it will be reproduced on the storage.
yeah, it is.
But
It is
if you
like a
don't,
reference. Yeah,
yeah, so it's pointing to the physical variable that we have here on on the mapping. So if you change it, it will persist. If you don't, it won't persist. So if you do this, if you set anything, it will only persist in memory.
yeah,
Okay, so the requirements requires that you didn't vote yet, and it requires that the delegate is not the same as the sender. So you cannot delegate yourself. Sorry. And it will, with this line, we will also guarantee that we are not setting to somebody that
circular
it's
delegations.
addressed that
Yeah,
it's addressed by 0. So we will see if there is a delegate of a delegate of a delegate that will circle around and point to you again, which, yeah, well, this is not a good idea to have circular delegations, because
yeah,
nobody will vote and it will be an infinite loop if you are trying to find uh, the delegate or the person or the wallet that it's supposed to vote. So that's why it fails here. If it finds the same address, it fails, saying that it's a looping delegation. And come on, these tooltips are quite annoying. Is there a way to remove those? Come on. Okay, so we are saying that, okay, so you already voted because you are delegating and setting the delegates to the wallet that you are passing as a parameter. So it's this one. And now let's summon the delegate, right? So let's summon the delegate structure and try to set some stuff there. One of the things is the vote count for, oh no, this is for the proposal. Okay, so we are setting, this code is weird. This code is
yeah.
weird.
That
Okay,
the reasoning behind
because we
that
are
is
only
that
delegating this. Why? Oh, okay,
yeah,
because he already voted. Okay,
yeah,
so if the
exactly.
delegate already voted, okay.
So if he already
Okay, makes
voted,
sense.
we add the our weight to the vote count. If we
Hmm.
didn't vote yet, it will add to our own weight, and
Yeah,
afterwards it would be using of our own, no, the delegate weight. Uh, it would use the delegate weight uh, to vote afterwards. That
yeah,
code
but this
is
is not
actually
very
not
coherent.
correct.
Yeah, it's
Uh,
not very coherent.
and we will see afterwards why. But and we will check that afterwards. So
Okay, yeah, yeah,
that is
yeah.
the
Go on.
purpose of delegation, and then the vote. Let's see the vote.
Yeah, so to vote, yeah, well, it speaks for itself. So let's vote on a proposal. So we are passing the index of the proposal. As you recall, before we have the proposals in an array, and we can index by using an integer, which will default to 256 bits. So let's summon the sender, which is the person that it's calling the vote function, and we will require that the weight is not zero. And yeah, this is one thing that this is not doing, right? It's not removing the weight from the sender, so it won't be zero. And it will require that it didn't vote. Okay,
Yeah.
so okay, I see that it's sending, at least it's
Yeah.
protecting by setting the vote to true,
Hmm.
but then again, the weights won't match
Yeah.
exactly the same at the end. So that's something that it's
Then
not good
sets
there.
voted to true and sets the
Again, so it,
proposal
yeah, yeah, and
to the
sets
vote.
the, yeah, sets the proposal, the chosen proposal there, at least the index, and then increases the vote count with the center weight, which is the weight that the voter has at the moment. And here we have winning proposal, which will iterate through all the proposals and check which one has a higher vote count, right? Yeah, winning
Yeah.
vote. Okay, so it defaults to zero, and then if it's higher, it sets, okay, it sets to the to the p, which is the index.
Hmm.
I don't like these names. Just call it the index or something like that. Okay, so and then we have the winner name, which is, it uses the winning proposal function that we saw here, which is a view, which is very efficient. And since it's yeah, because it's accessing the storage, it cannot be a pure function. So this again is checking the name or winner name. Okay, so it
Yeah.
will return.
It
Yeah,
is the
it
name of the
returns.
proposal,
Yeah,
basically.
it returns the name of the proposal here. So yeah, this is it. Shall we go through
Yeah. Let's
this?
let's deploy it and let's try it out.
Boing, deploy. Let's clean this up. Let's choose the first one so that we don't mess up that much, and deploy. No, cannot deploy.
You
Why
need to
not?
pass
Ah, no.
proposals. It's an
Uh,
array
yeah, how
of
do we pass a rate here?
strings.
So it's just stuff like this.
Yeah, probably it is something like that.
Proposal one, proposal two, and proposal three. Yeah, okay. Deploy. Error. We have errors. No?
No,
No? Oh, I saw error here. Yeah, we have errors.
we have
Why?
errors.
Creation ballot errored. Let's see. Let me see the constructor here. Why? Encoding arguments, type
No,
values
that's another
mismatched.
thing. Yeah, put square brackets around the proposal names
Yeah.
and
Yeah.
pray. Praying in these things is very
Yeah. Yeah,
important.
it helps a lot. Yeah, you didn't pray enough.
Not enough.
Yeah, no, it's worse now. Invalid argument. Don't make me Google for this.
I can Google for you.
Proposal name. So why is it doing this? This is not good. Parameters. This is weird. Proposal names. Why is it not adopting all the stuff that I put there? It surpasses me. Let's see if
Yeah,
it's
it has to have square brackets and um, and double quotes.
yeah, and commas separating, right?
Yeah.
Okay. It's not working. Not working. Houston, we have a problem. Okay, so value proposal one.
A valid
Why?
argument. It's because it's bytes 32. Uh,
Why do I
it
care?
should. It should. It
This
should.
should be converted, right?
Let me check.
Don't make me write in
In hexadecimal.
yeah. That would be fun.
Yeah, it seems that it has to be
Yeah,
hexadecimal. Sorry.
I don't care. Let's change this to string.
You can.
Any error? Yes, errors, because this will be a string also. Right? Right?
Yeah.
Wrong. Why? Data location must be memory or call data. Okay. String memory and build. Clean this up.
This is. Um,
Yeah, guys,
just
we are learning with you
just
guys.
just for not having to write 32 bytes of hexadecimal shit. Miguel is that lazy.
Yeah. Proposal 3, and let's see if this works. Come on. What are you doing? Oh, this. Ta-na-na-na, there we go. And we are passing all this stuff here. We can we actually see? It's public. The proposals are public. So let's see if we can check them
Yeah.
out. Okay. So get proposals. Where are the get proposals?
Proposals.
This is
That's one.
no this.
Yeah, just
No.
pass the index and that's it.
Yeah. Right.
Proposal 1.
Ah, yeah. It's okay. I see it. Let's see the last one, and let's
Yeah.
see the one that should fail. So
Mm-hmm.
there we go.
It's failing.
Yep. Nice. Okay, let's clean this up. Now, I don't. Do you really want to go through this delegate stuff?
Why not?
Yeah. Okay, let's go.
So first you need to create a few voters. So you need to use that
Yeah.
function and copy another address. Use that address, but copy
Yeah.
another address
Okay.
for.
Yeah, we don't need that because it's the sender. So.
You need
Oh,
because you
yeah.
have
Yes.
to
Yes.
you have to be the
I got it.
deployer.
I got it. I got it. Copy.
Click there.
Yeah, I did.
Yeah.
And now give right to this guy, and poof. Now let's get another wallet. This one, copy, get the first one, and paste here. Doof, we have 2 of them. 3 should be enough, right?
Yeah.
Okay, so we have 3 voters. Do we have
Good.
voters?
So
Okay, address. Okay, let's see. Let's try this. Get the voter with this address. So we
has
have
weight
a weight.
1.
Yeah, it didn't vote yet. Doesn't have a delegate, and it doesn't have. It didn't vote on any proposal. Actually, this
It's wrong.
It's wrong because proposal number 0 is valid, as you can see.
Another
here. Proposal. This is a bug. So
another
it's
another
proposal
not
1.
very good.
But if you match this variable with this variable, it's kind of fine.
But
Yeah.
it should be avoided. Stuff like
Yeah, exactly. Yeah.
that is unintended should be avoided because sooner or rather than later, it will.
Yeah, it will mess you up.
Yeah,
Okay, so we can see the winning name. It really also returns proposal one, which is a bug, and the winning proposal it will say zero because it's proposal zero. It's the zero index. And it works just the same as we were saying that the it will seem like this guy voted for proposal zero, and it actually happens the same if you get the winning proposal, which will return you zero, and it's perfectly valid, and it shouldn't because nobody voted on that. And the winning name also proposal one, which is invalid because nobody voted on that. So yeah, this kind of has some bugs here. So let's
that's
check the
why
chairperson.
we call this episode "Dumb Contracts." Right?
Right. We can see that the chairperson is the deployer of the contract. We can see it here. And yeah, so let's try to vote, right? Oh, well, let's delegate first. Okay.
Yeah,
We are going to put the third contract as a delegate of the second one. So delegate to this one, but then we need to use this one. Let's try it out. Clean everything so that we can see and delegate. So we have a successful call, and we are delegating to this third address. It ends up with ABAB. I like that address. Yeah, it's ABAB. And we're good to go. Let's check if the delegate give not this, yeah, the voter. It's this. Copy this address and voters. Now we should see that we have a delegate here.
yeah. And we have a
Why do we
weight.
have a weight of one?
Exactly. It's not
This, yeah,
setting it.
yeah. It
Uh,
shouldn't. It should have
and
a weight of zero at this moment, and the delegate should have.
the weight corresponding to that one. Exactly.
And it has to, yeah, which is fine. It's like it's supposed to be. So, but the other voter, the previous voter, shouldn't have a value, shouldn't have a weight at this moment. So this is a bug.
Yeah, and it's a
But it's
bug that.
saying, well, yeah, it's saying that it's already he already voted, so we can ignore kind of. But it's not coherent to do stuff like this.
Yeah, and you cannot undelegate, which is also
Yeah.
weird,
Yeah,
right?
because if you set the delegate to zero, it will mess
Let's
things
go
up.
to the delegate function.
Yeah, yeah,
No. To in the code,
yeah, in the code. Okay.
the delegate function. Uh,
Yeah, well, if it's
so
zero, you fuck this up.
yeah,
Yeah, it will be fucked up. And the weights do not correspond. So yeah, actually,
actually, if it would
yeah,
be allowed, if you would pass zero, that voter would be uh, it wouldn't work anymore.
yeah,
And
it would be totally annihilated because it's saying that it already voted. It wouldn't have a delegate, and yeah, but no, not really. It would say that it would vote on the proposal zero because voted is true. So it would be has this guy voted on proposal zero. So yeah,
yeah,
so
let's
there are
try. Let's
quite a
try.
few, but you want to put it to zero? or
Yeah, why not?
you want to vote?
Now let's vote first, and then let's break the thing.
It's already broken. What are you talking about? Okay, so let's vote on the with the first one.
Yeah, let's vote with the delegatee.
No, no, no. Let's vote with all of them. So okay, this one will vote. Let's see if it went well. No, it failed. Why? Revert. Why? What? Function should be payable?
Nope.
What? It shouldn't. It's not paying anything. Okay, let's check what the hell is going on here. Where's the vote function?
So it is reverting without a reason.
Yeah, so it's not about this requires. Yeah, let's clean this
Clean
up.
that and
Vote again, yeah. So, okay. Transact ballot vote.
do you have some value on up in the fields on that side? On the deploy side, go up.
Wait.
No, value is
Yeah.
0. Strange stuff.
Yeah, because this is a proposal. So let's propose one.
Ah,
Not an address. Okay, let's clean this up. So it was actually invalid parameter, but well, it was not that obvious, the error.
yeah.
Yeah, it doesn't say anything
Yeah,
about it.
it's completely useless information there.
Yeah. Okay, let's clean this
So
up.
1, and you have to send. Yeah, exactly. That's
Yeah,
it.
so we voted on the first one. Let's check it.
Can we vote again?
Yeah, we will try. Okay, so we will see. We voted on proposal 1, which is nice. Voted to true, wait, and delegate. All fine. Let's try to vote again. Let's clean this up and vote. No, you cannot. Already voted, which is fine. It's
Good.
cool. Nice. I can break this. Well, no, actually not, because yeah, it's already voted, so it won't. I was thinking that I could now delegate the vote to somebody else, but no, you won't be able to do that. Okay, so let's try the second wallet, and let's vote. And this guy shouldn't be able, because this guy delegated his vote to somebody else. So let's vote on proposal 3. Well, let's check it first.
Doesn't
Let's copy
exist.
the address. Yeah, actually it doesn't. Okay. Let's check this guy. So this guy is the one that delegated. It didn't vote. It should fail. Okay, so let's vote on proposal 2, which is valid. Clean and vote. Okay, it says already voted, because the vote is delegated. Let's try on number 3 with. Let's see if we get. Yeah, already voted. So yeah, okay. We cannot see the error, like failing to vote on a good proposal. We will try. Do you want to try anything else with this guy, with this wallet?
No, let's
Okay, this is
vote
the
the next
delegate.
one.
Yeah,
Yeah.
this guy is the delegate. So the delegate will have a voting power of 2. It didn't vote yet. Nice. Doesn't have a delegate, so it's not delegating to somebody else, and it's saying proposal 0, which is wrong. But we will try to vote on number 3. Clean. This should explode. Okay, it did.
Boom.
Okay. what's the error? Transaction has been reverted to the initial state.
Mm-hmm.
It should be payable. Well, it's just the
Yeah,
same error. It's just stupid
it's
errors.
useless information.
Yeah, it's just
That
addressing
means that
something that it,
proposal index 3 doesn't exist because we have three proposals in the array, which is index 0, 1, and 2,
yeah.
right?
If you want to do this properly, you would have something like require that proposal it's minor or equal to proposals dot length. So you should do something like
And
this.
with a message, please.
And with a message, of course, yeah. Out of bounds, yeah. So it's a good message. Why
That
is
is a
it
good
red?
message for a developer, but we should
Yeah,
put always messages
yeah,
in the contracts that the user can understand,
yeah,
right?
yeah, exactly.
So
Like
that
the
in,
proposal does not exist, something like this. So
exactly,
it
that
should
is
be pretty
understandable
obvious.
for a user.
Yeah. So yeah. So yeah, but we are not going to compile this right now. We
Yeah,
are. Yeah, I was just showing it should be done because it would revert with a valid message that it's not this, which is
yeah.
totally void of content. It doesn't mean anything. Okay, so let's get the voter again. Yeah, it doesn't exist. So let's vote on proposal 1 and clean this up and vote. Valid.
And the
Nice,
delegator,
nice green
the
stuff.
delegatee voted, and
Yeah.
we
Let's
should
check this
have
out. We have voted to true and vote on proposal 1. So now we can get the winning proposal. Can you guys guess which one? Which one was it?
one.
Yeah, it should be 1, and it is 1. And the name is proposal 2 because I missed to think on zero index arrays. So it's proposal 2, which is fine. Let's try to vote
Eh,
again. It should fail. Already voted.
mhm.
It's fine.
Now let's do delegate to the address 0 on some of those to see what happens.
Okay, so let's get this one, which is the one that delegated. Let's copy the address and voters. Okay, so this is the one that has a delegation. So let's delegate this to 0. Clean and poof. Invalid address. Come on.
You have to pass.
Yeah.
No, it doesn't work like that. You have to put all the zeros.
Really?
Yeah,
Ah,
it's annoying.
it's 32 zeros, right? Come on. Yeah, 32 zeros.
Let me check how many. I don't.
It's 40 zeros.
40?
40 zeros. Okay. There we go. Thought it was 32. Why? Okay, already voted.
Yeah, it
Yeah,
doesn't.
so it's fine. So it's this here, like, let's go to the delegate function, and it's saying, well, if you already voted, it won't allow you to delegate anymore.
But you can, if you didn't vote. No, but it marks you as voted when you
Yeah,
delegate.
yeah. It kind of protects you like that. But it's not coherent. The data is not coherent internally. So I
Yeah,
don't like it. Not the way I would
it's
do it.
always one thing that we can see is that when the voter delegates, if he delegates before voting, before the delegatee voted, uh, it will have one result. And if the voter delegates after the delegate had voted, the result will be different because the weight on the delegatee will not be updated because it will update just the proposal.
Mhm.
And so in one route, you will have the weight of the delegatee uh, one, and on the other route you will have the weight on the delegatee two.
Yeah.
And this is not very bad in this contract because it doesn't
Yeah,
make much difference.
it protects you with the
But
vote,
these
with the
things
voted.
these things add up. And if you continue developing this contract and creating more functionality and so on, you might end up in a situation where things
Yeah,
get
well,
really
if you are
messy,
not
right?
coherent, if you are not coherent with your data, it will bite you for sure.
Yeah. So uh, how do we correct this difference? It would require us to remove the else clause on the delegates. If you go a little bit lower on the code that you have, that else, just remove that line and no, the else line, and that one
Hmm.
can be there. Yeah, like that. And this would mean that the weight would be set anyway, right?
And
Uh,
and this.
and that would be also setting, removing the weight power from the user that
Yeah.
delegates, so that everything stays coherent, right?
Yeah.
Uh, and I always advocate for getting all the things in a good shape, uh, so that there is no route that might change the results in a way that we don't predict. Right?
Yeah.
Predictability of blockchain code is one of the most important things.
Hmm. Yeah, I do
Right?
agree. Yeah.
And yeah,
Okay. Yeah, we wanted to make one contract from scratch, but this took quite some time.
yeah, and I think it was fun. It was a fun introduction to smart contracts. And
Yeah.
next week we will do one from scratch anyway.
Yeah.
So
Yeah. Let's do something like let's wipe all this up and try to make a smart contract from scratch.
yeah,
I
let's
think
do something useful actually next week,
yeah.
because
We
this
can
this
we can
was
also
just
go around here the debugger and I don't know, maybe we can come here and check the deployment scripts. Those are quite easy to understand. Just
yeah.
deploy. This has to be the name of the contract that you have. So if we are going to this storage, it will have to be exactly this name. And these are the parameters that you want to pass on the constructor console log. Yeah, you guys know what this does. The same thing for yeah, this is for ethers and this is for Web3. When you either using ethers or Web3 for JavaScript. And here is the deployment of what
That
of
is
what
the
contract.
that is the libraries. Yeah, for deployment.
The
Yeah, and
And we also have the test. So we have test in Solidity, which is just a contract that it's calling the ballot contract. This has errors because we changed the names to strings instead of byte 32s. So this is just going to call the functions. And the difference is it's running on the blockchain. These tests are running on the blockchain. These are tests running outside the blockchain in JavaScript, which are just calling API functions to the blockchain.
yeah,
So
and
I don't know if it makes sense for us to go
no,
through
no.
this.
I
Yeah.
really think that you should pick one way or the other. If you like to use blockchain tests in Solidity, you should use Foundry for that.
Mhm.
If you want to write tests in JavaScript, Hard Hat is the way to go. So, but that is
Yeah, you can actually use a mix of both
you can
without
exactly.
a problem. But yeah, you should. Yeah, because both of them have advantages, and so you should pick depending on the test. You should pick which approach you should take. But yeah. If you want to go mainly on Solidity tests, you should go to Foundry. If you go into JavaScript tests, you should mainly go
But
to Hard Hat. Yeah.
but we can talk about that in a separate episode
Yeah, yeah,
because
yeah.
the
Yeah,
test seed is a completely different thing.
yeah I just wanted to cover
Yeah, yeah, yeah.
all the files that we have here. Also,
So
read the file if you want to
uh,
go through this, and a pretty
I really
file.
recommend you guys to learn about tests and properly test everything in your contracts. All the values that you can pass to a function should be tested, and you should have a
Sometimes
very nice
repeatedly.
coverage. Yeah. So that you are certain that everything works as expected and so on. And it's always better to have more tests than needed than have less, because
Yeah.
usually the things that you don't test are the things that fail. So
Yeah,
that's the
the
way.
other ones you just find them by testing, right?
Yeah.
So
So
if you are not testing, yeah, the ones that fail are the ones that you did not test.
yeah. So yeah, I think that this was a nice introduction to a little bit of Solidity, a little bit of Remix IDE, and deploying contracts and calling functions and all those good things. And next week we will build something from scratch. So if you want to join the fun, welcome. Come back next week, same day of the week, same time as usual. And yeah, I hope this brought some good information for you guys starting out. And yeah,
Yeah,
let's
wait, guys! Don't forget to like, don't forget to subscribe, and don't forget to share this video with your friends and your social media. So
and
yeah,
yeah, check out our Telegram group. Get in there.
yeah,
Uh,
post us some
Connect
questions if you have any
with the
questions,
community.
doubts. just
Yeah.
post us a message there. We'll try to answer as quickly as possible.
And have fun with developing smart contracts. Not that dumb as we did today. Let's build something useful. But yeah, this is a lot of fun. And so, as usual, guys, welcome to our mission to decentralize the world
wisely.
And let's get back next week for more nerdy stuff. Cheers, guys.
See you on the
Bye-bye.
next one.